Hello and welcome back. So this is chapter 2 of the first course of Python Essentials. So we'll have a quick review of the last session, then discuss functions, specifically the print function, go through literals, which are our data types, strings, integers, floats, boolean functions, operators, variables, leaving comments in our code, and converting some of our literal types. So in the last session we discussed the makeup of the two Python Essential courses. We went through the fundamentals of programming, how the language is structured, the differences between compilation and interpretation, why we should use Python, how it's positioned in relation to other languages, the different variants of Python that are out there, and setting up Python on our machine using the inbuilt idle or adapting the features for Visual Studio as we used Visual Studio in C# unit, which the students just completed. So function print. So this was the very first program that we created at the end of last session. It was a simple print hiss function, and a function will cause an effect or evaluate and return a value, and they can be built into Python or an add-on module or a function defined by yourself. Now, the syntax for functions is the function name followed by the parenthesis with arguments defined within. So the good old brackets. Alright, so here the function was print, and within the quotes was our argument, which was to be displayed within the console. Now, our argument was in double quotes, and that told Python that it's to display it. Now, several things occur when Python goes to execute a function. They'll check whether the name is legal, whether all the arguments for that function have been met. Python will then step out of your code to execute the function. It will then return the effect or the value and come back to continue your next line of your code. So basic function or criteria is one function per line. So for our print command, that was on a single line. Now, if you want to break up how it displays on the screen, if you use just print with an empty parenthesis, or print a blank line out to the console. We can add things inside of our text by using a escape character, which is the backslash. And the most common one we use with this is the \n for new line. So that's another way of putting a line between text to affect the display. If you actually want to use a backslash within your text, you have to use double. So that tells it that it's not a break escape character, it's actually to put in that backward slash in the text. Some of the other escape characters: carriage return, tab, backspace, form feed. So there's quite a few up there. When we want to specify multiple arguments for the function, we can separate them using commas. This is interesting in that it varies from, say, C#, in that we don't have to alternate between the arguments using the plus sign to stitch them together. It does it automatically. And it also puts a space by default between the arguments. So you can see here the output is quite a readable sentence, because if we did the same thing in C#, for example, these two, the spider client, would be added directly together. So nicer way of implementing it, I'll just say that. So we can affect how that default view occurs. So we can, using a key equals value argument at the end, we can affect how material is stitched together and how it finishes a line. By using the end equals, in this example here we have it equals a space. The default is effectively a new line, okay? So we're no longer creating a new line, we're just going to put a space between the first print function and the second one. So it will display it on a single line with just a space between the two. The other thing we can change is how the arguments are separated on display using the sep equals keyword, and in this example we've put a dash in instead of the space. We can actually combine multiple keyword arguments at the end to affect our display. So again, we're changing the separation and ending of the first print statement, which will force the second one to continue on the same line, and then create a new line at the end of the second print statement. Little activity for you to jump out and do to get you used to coding is, you can see there the required output. So your job is to actually go create the code to replicate the wording there. So Python essentials in programming essentials in Python, and then the Christmas tree or the arrow, whichever way you want to interpret it. Now moving on, due to the power of video, I know you've hit the pause button and went and did that coding. So literals are our data types. So it can be a string or an integer, and numbers are our usual integers or floating point. So integers, if you remember your maths, is whole numbers, and floating point is our fraction numbers, so 2.5 for example. Now, depending on where you are in the world, you will represent large numbers with either commas or decimal points or spaces to break it up between your groupings of the thousands, hundred thousands, millions, etc. Python doesn't allow you to do this. It's got to be consecutive numbers, or if you want to have it more readable, we can use an underscore to do those spaces so that we can read the number easier. So within good old Python, we will have different integer types. So we can have octal numbering, which is values between 0 and 7, giving a total of 8 combinations. When we wish to display or work with octal numbers, we'll have a prefix of 0, O. So 0 the number and O the letter. This tells Python that the following number is in octal format, and that will do an automatic conversion to decimal if it's a print statement. Same with hexadecimal digits, which gives us 16 combinations, 0 to 9 and A to F, and we'll prefix those numbers with 0x. Now, hopefully you've noticed on the slide that we have it in capitals or lowercase. It makes no difference. So, as a jump out again, get you to do the activity of printing out a value in octal and hexadecimal. So what is the decimal value of 55 in octal and hex? Now, give you a hint. Octal is base 8, so it's going to be lower than 55. Hex is base 16, so it's going to be larger than 55. We know this because decimal is base 10. And through the lovely function of hitting the pause key, you've gone off and done your coding and gotten these results. So octal is 45 in decimal, and 55 hex is 85 in decimal. Quick, easy way of converting numbers. So that was integers. Next is floats. Now floats, you need to use a decimal point. If you try to use commas, you'll get an error. Also, Python will always use scientific notation for large numbers. So its basic function, if you like, is to display numbers in the most efficient and concise way it can. So instead of displaying the 3 and 8 zeros, it's just going to be noted as 3E8. So the E is the exponent, so it tells it how to move the decimal point back and forth. If it's a positive number, it moves it to the right, so it adds zeros after the number in front of the E. If it's a negative number, it moves it to the left, as per this example. So here we have 2.1 E negative 21. That tells it to move the decimal point to the left 21 times. Just so you know what's going on when you see it displayed. Next up, we're used to using the double quotation mark to signify a string of text to display, and traditionally to get quote marks used in the output, we would use the escape key in front of it, telling it, Python, to actually display a double quote rather than having it finish the display. Now, interesting, we can use apostrophes instead of a double quote. Now, when we want to use the good old quotation marks within the output, if we use the apostrophes as our delimiting string, we can put the quotation marks in our string and get it to display as we wish. No need to use that lovely escape key. Just be consistent. Next up is boolean functions, which are either true or false. Just be aware that true and false is case sensitive, and true is always more powerful than false. So true is greater than false, returns true. True is less than false, returns false. So the truth is all powerful. Another activity for you to jump out and do a print function. Now, the output is on 3 separate lines. The goal of this activity is for you to do it in one print function command. Okay, you've gone off and done it. Here's the solution for you. Alright, so lots of little double quotes and apostrophes. Moving on to operators. So these are good old math functions. So your normal addition, subtraction, multiplication, division, modulus, which is remainder, exponents, which is the to the power of. Floor division is an interesting revision of the normal division. Okay, so good old to the power. So 2 to the power 3 will be shown as 2 double asterisk 3. So the number in front of the double asterisk is the base number that we're going to apply the power to. The number after the double asterisk is the power of. Now, if you are using integers, the result will be an integer. If you have a float in one of these, the result will return as a float. Now, as I said, the lovely double slash, so this is different to the normal division. This is floor division, and what it basically means is it's going to return the default number of times something is divided with no remainders. Alright, so it's going to round down the result. So in the example we have 6, floor division 4. 4 goes into 6 once, rounded down. Second example there, we've used a float, so 6.0 divided by 4 is 1.0, rounded down. So using the floor division will only tell you the whole division number, so it doesn't return any fractional results. Next up is our modulus, which is remainder. So 6 divided by 4 gives us a remainder of 2. Again, if we use a float, we'll return a float. So how does that actually work out when we're doing the calculation? So 6 divided 4 is 1. 1 times 4 is 4. 6 minus 4 gives us 2. So the remainder is 2. I know that was a long-winded way of coming about it, but that's the steps that it takes. So 12, floor division 4.5, it's 2, which is 9. 2 times 4.5 is 9. 12 minus 9, remainder is 3. Unary and binary. So something that we fully do by natural process is we do the positive and negative values. So using the plus and minus sign to change the value from a positive or a negative, we kind of take by default now. So Python can do the same thing for us. It can change the value. So if you're like me, you continually forget the nightmare of mathematics. No. Most of us don't do a great deal of mathematics day to day. But there are rules around which functions occurred first. So these priorities are still available under Python, and they are read from this little table from top to bottom, and when there's more than one on a line, they are read left to right as far as priorities go. So our groupings, anything in a quotation mark, the exponents, positive, negatives, multiplication, division, remainder, then good old addition and subtraction. This is the order that these things will occur. Why is it important that we know which order equations are performed in? Because the output can be drastically different if we don't know the priorities. Now, when we come across an equation that has multiple functions, operators that are the same, so that means the expression has the same priority, we then have to take into consideration the left or right binding applied. So if we look at the first example here, print 9, remainder 6, remainder 2, gives us two very different outputs. So if we do left to right, so the first equation is 9 remainder 6, which gives us 3. Then 3 remainder 2 gives us 1. If we do it right binding, that's 6 remainder 2, which is 0. And then when we go 9 divide by 0 to get the remainder, that produces an error because we're dividing by 0. Quite a different output. Okay, second one, using exponents. 2 to the power of 2 to the power of 3. So if we do it left to right, that's 4. 4 to the power of 3 is 64. If we do it the other way, right to left, 2 to the power of 3 is 8. 2 to the power of 8 is 256. Again, quite a different result. So we need to know the orders, whether it's left or right, and how it's done. Now, the nightmares of maths come back to haunt you. With pen and paper, try to work out the following expression. It's not too difficult if you step it down. Alright, so have a look. You see there's multiple brackets. Just eliminate one at a time to come up with a new line. So the first one, 25 remainder 13, gives us 12. Now that is a bracket inside a bracket, which is with the plus 100. So that's 12 plus 100. Over here we have a division, then a set of brackets. And to eliminate this set of brackets, 2 times 13 is 26. Close off the bracket. Then eliminate this one, is 112. Then what comes first, the multiplication or the division? Multiplication, then the division, and that resolves to 21 floor division of 2, which returns 10. Now, I'm not suggesting that we break down a formula into base values, because generally a formula would be made up of variables. So the actual result would be quite different each time the variables will run through the equation. But what you do need to know is how the equation is calculated, so that if you're not getting the results that you would expect, you can look at a complex equation, break it down into the steps to work out what it's doing. Why is it important? It helps you troubleshoot your code if you understand the step-by-step process that it goes through. Okay, variables are a container that contains a value, whether it's a string, a number, whatever. There's a naming convention for variable names. They must be composed of upper and lowercase letters, digits, or underscores. It must start with a letter, and for this, a underscore is considered a letter. Upper and lowercase characters are treated different. So an x, lowercase x, is a different variable to an uppercase x. We need to avoid duplicating any defined keywords that are in Python. So there's a whole set of defined functions and keywords, such as delete, return, pass, else. So things that call Python to do specific, well-defined things. We can't reuse those names to define a variable to do something else. So a variable format is name equals value. So var equals 10. And if we then printed var, it would display 10 on the screen. So again, a little activity for you to shoot off and do. So, apples are us has John with 3 apples, Mary with 5, and Adam with 6. So we want to display how many apples each person has on a single line, calculate the total number of apples between all members, and display the total number of apples on a new label with a statement that represents that total. So I know you've jumped off and did the little lab just to work it out on your own. So a possible solution would be John equals 3, Mary equals 5, Adam equals 6, tote equals John plus Mary plus Adam. Then we have our print statements with the arguments separated by commas, and then followed by total number of total apples. Now, good old Pythagoras theorem. So the hypotenuse is equal to the sum of the squares of the other two sides. So that means we've got to do a square root function to work out the hypotenuse. Now, we did 2 to the powers, but we didn't do square roots. How can we work out a square root? Well, it's quite function. Well, a square root is half of the power. So, A is 3, B is 4, So C is the calculation of a to the power of 2 plus b to the power of 2, and that is done to the power of 0.5, which is the square root. So we then can print out what C, or the value of the hypotenuse, is, which is 5. For those that can do quick maths, 3 to the power of 3, or 3 times 3 is 9, 4 times 4 is 16, and then together is 25. Square root of 25, 5. Simple 5 times 5 table. So, shortcut operators. So, rather than doing x equals 5 or x equals x plus 3, we can shortcut that to x plus equals 3. Why? Because if we're doing a lot of these, it saves a few characters in the source code. The smaller the source code, the more efficient it is to run. Throughout our code, we should place comments. Now, these comments are there for us humans because comments are not read by Python. So we use the hash symbol or pound, depending on what documentation you're reading, how it reads it. Once it sees that symbol, it ignores everything behind it. So you can have comments on its own line, or you can place it after active code on that line. What you should include comments for: describing how the block of code works, the meaning of variables, when it was written, and who by. Python is designed to be modular. Okay, when you're working on projects, it's splitting up into separate sections so that individual teams can write part of the code. So they write their own code, and then all those pieces are reassembled to the final product. So it's good, and I've got to remember to take that display pause out. So comments is also available for when we're doing testing. We can not action a line of code by putting the hash in front of it. That makes it a comment, so it won't be actioned. So we can use it for testing sections of our code and how different versions of code affect the output. Otherwise, we want to put comments in to explain what we're doing. So first couple lines explain what we're doing for the calculation. It's hypotenuse of C. Then comment after the C calculation line, double asterisk 0.5 instead of the square root. So we're putting in an explanation of what we're doing. Next function we'll look at is the input function. This is how we can gather information from the keyboard. So this displays a flashing cursor, which indicates that it's waiting for keystrokes, followed by the enter key. Now, it's no point in having an input if it isn't paired with a container to put the input into. So we should always pair it with a variable. Now, the input argument, if you have a value in there, it's the message that's going to be displayed on the screen as you're waiting. So there's no need to have a separate print function asking the question and then waiting for the variable. you can just put the input statement in there and put your message in as the argument. That is going to be displayed as the question. It doesn't go into the container as the result. Only what comes in from the keyboard is recorded as the result. So, string is a collection of keystrokes. That's your default input, really. So if you want to gather a number as the result, then you really need to specify the data type as you input it. So here's an example. Variable equals int input. So that's telling us that the input expected is going to be in the form of an integer that's going to be recorded against the variable name. So, if you remember back when we were talking about the print function and that the arguments add this space, if we just use a plus symbol instead of the commas, it's going to do something a little different. It's going to actually stitch those values together without a space. So we can do interesting things by using a combination of the plus to stitch things together, as well as our separators and end keywords within the print function. So within that, think about how things are going to display. And one of the other things that is quite interesting is the combination of strings and numbers. So if you want to repeat some text, we can do that by simply specifying the string and then using the asterisk and the number of times that we want it repeated. We'll have multiple displays outputted with a single command in our code. Within our conversion of integers into string, a very easy string function will do that for us. Now, this is the safest way of converting our numbers into a string so that it's treated as text. It's almost impossible to make it fail. Almost. Us humans are creative. We can do anything. Alright, so with the end of the module 2, there are 3 labs that you need to run through. Each will take roughly 15 to 20 minutes, so there's about an hour's worth of lab time for you to do. Alright, now if you're listening to this and you're not part of the group for the class, you won't have the activity handouts. So just complete the labs and any activities requested as you go through the module, and you'll be good to go. So in summary, we had a look at the print functions, we had a look at what literals are, we had a look at the strings, integers, floats, boolean functions, looked at our common operators, defined what variables are, how to inject different values into them, the naming conventions, how comments assist us with documenting our code so that when we come back to it 6-12 months later, or somebody else has to do a change, it explains what we're doing with the code at any given time. And then we had a quick look at converting numbers into strings using the string function. And that concludes Module 2 theory presentation. Please ensure you jump out and do those labs. Alright, until next time, it's bye from me.